Your default microphone has changed. Actually, now you can hear me, right? Yeah. Very good. All right, everybody in Zoom land can hear me. Good. Sorry about that. Let me get my screen back up here. This over. Well, it looks like we're a few minutes past 12, so why don't we get started? Hi, everybody. My name is Frank Donnelly. I'm the head of GIS and data services at the Brown University Library. I'm part of a little center called CLEAR, and part of an even littler group within that called CLEAR Data Services. My colleagues, Cass and Nia, are actually here in the audience today. And what we do is that we provide an array of data services to support research and teaching at the university. And what we're going to be talking about today is the Data Rescue Project, and a little bit about how you can do screen scraping with Python. So at the beginning of this year, obviously, there was a change in government, and with the new administration, there were a lot of concerns about data sets being removed from the internet. And not only the data sets, but even the agencies that produce them being removed. So there have been a number of preservation projects that have sprung up to save and preserve these data sets. I'll talk a little bit about some of those projects, primarily the Data Rescue Project, and a little bit about what we've been doing at the Brown Library to participate in that project. So the first part of this is kind of an overview about that. And then the second part will be more of a hands-on piece about how you can screen scrape websites to download data sets that are there using Python, which is one of the many approaches that we've used in the data rescue work that we've been doing. Before we get started, I was asked, actually, you can't see folks in the audience here at the top of my slide. This is a little code thingy that you can take a picture of, or you can punch in that bit.ly. This is just to show that you've registered and are attending the workshop, because the fine folks at the DSI would just like to know that. So you can take a second to do that now, or if you don't have time to do that right now, I'll have this slide up again at the very end of the presentation too. If you want to fill it out later, you can do that. All right, just checking the chat, making sure life is good. Okay. So once data sets and things started disappearing, I mentioned that there are a number of initiatives that popped up to preserve data, but there are some long-standing projects that have been around for quite a long time, which are good places to turn if you're looking for something that's not there anymore. And I wanted to give some attention to the Internet Archive, which is a project that is about as old as the internet itself. It's a nonprofit project. And as the name says, its job is to basically archive everything that's on the internet. So if you have a URL, a link that is broken and not working anymore, you can plug it into this tool called the Wayback Machine. And the Internet Archive will look through its archive and give you a little calendar. And you can pick a date in the past and basically open up that page and get access to it. Or even if the website isn't broken, if you just want to go back in time and get an earlier snapshot of it, this is really a great tool for doing that. So you're able to uncover a lot of stuff that has been lost. It is not perfect. Not every web page is captured. Not all of them are captured at a regular basis. And if the website was particularly complicated, if it employed a lot of architecture under the surface where it was a database-backed page, or it uses some archaic scripting stuff that's not used anymore, the page may not be preserved perfectly. But this is always a pretty good place to check out. Beyond the Wayback Machine, there is also the Internet Archive allows all kinds of folks to create dedicated collections of documents, data sets, images, all kinds of things. And you can basically crawl through and search through all of these different like mini repositories. So this is an example of an official one that was created by the USDA to house a lot of their reports and their documents. But then there are other collections here that are created by data hoarders or people that are just interested in a certain thing, and you'll be surprised at the kind of stuff that you can find in there. I was helping somebody, we were trying to find old issues of TV Guide a few weeks ago, and there are actually a lot of them in there. But this is a place where, a lot of people are archiving data sets. So it's also another good place to look. And it's nice because it's an open project that anybody can participate in. But beyond, the Internet Archive, I mentioned at the beginning of this year, a number of projects have popped up that are dedicated to preserving data sets. The Data Rescue Project is one of them. This is an initiative that is basically directed by a lot of librarians, archivists, some nonprofit organizations, also some data hoarder folks. And their specific goal is to basically serve as a clearinghouse for all data rescue projects. So they keep track of all of the other projects that are happening right now. They try and keep track of all the data sets that those projects are saving. And they have their own internal effort where people are volunteering to save and preserve data sets. So one of the resources they have, if you go to their website, they have like a basic list of all of the different projects with the contact information of folks that you can go there and check out those projects. They also have this data portal. What this attempts to do is for projects that are very small bore, where are saving individual data sets, they've created this database of all the data sets that have been saved. So if you're concerned about something or something has been removed, you can take a look in this portal and figure out, well, where did it go? Who saved it? And then beyond keeping track of what everybody else is doing, they have their own internal effort to save data sets. So this is a screenshot of an inventory spreadsheet. It's basically just a Google document. And what the directors of the coordinators of the project do is that they would get news that, oh, an agency is in trouble, or there are particular data sets that we think are going to be removed. They create a tab in this spreadsheet. Somebody would go in there and list all the data sets they could find for that agency with links. And then people from all over the country, actually all over the world, would come in here and claim individual data sets. And they would go out there then and be responsible for downloading and saving that data and then eventually uploading it somewhere. So it is pretty amazing. It's like this totally crowdsourced effort that, I don't know, at least hundreds of people have participated in, and thousands of data sets have been saved this way. Where do people actually put the data sets that they've saved? There is this repository that the data rescue folks are using called Data Lumos, which is hosted by an organization called ICPSR. ICPSR is a large social science research center at the University of Michigan. It's one of the oldest social science research centers in the country. They have their own repository where they host like research data sets. So if you're part of a big research project, this is a place where you can host your stuff. And then Data Lumos was spun off as a separate repository specifically for keeping copies of federal government data sets. So once the Data Lumos people, once the data rescue people, you claim a data set, you go ahead and scrape it and download it, and then you can upload it into Data Lumos, which is the platform then that makes it available to everybody else. Part of that process, though, is that it's not just about the data, but it's also metadata. So when you put a data set in these repositories, people need to be able to find it. The only way they can do that is if we have a metadata record that, with a description, the authors, information about the dates. So a big part of the work is actually the volunteers are also writing this metadata when they're uploading things to the repository. In some cases, we can rely on metadata that the creators of the data set have written. But in other cases, you have to do kind of your own investigative work and figure out how to describe it. But Data Lumos, as I said, is a public website, so you can go there and do a search. There are over 1,000 data sets in there right now that have been rescued. So the Data Rescue Project is something that I became involved with like back in January when I was kind of worried about, well, what's going to happen to some of the stuff that I use all the time. So I started volunteering with the project back then. And then within a few months within the library, we got a little group of people together across several departments. And we formed a little group where we were working and collaborating together and going out here and rescuing data sets. One of the early things that we did is that we created this research guide. So in the library, we have tons of research guides that are devoted to like every subject. Within our social sciences guide, we have a page that basically just gives you like the top 10 resources that you can look at in terms of alternate sources for data if data sets go away, or some of these projects and repositories where you can look to find things. Beyond that, there's another group in the library that serves the health and biomedical library services team. They work very closely with the School of Medicine and also with the School of Public Health. And there are like a parallel set of concerns about medical information and medical research being removed. So what our colleagues have done is that they've created this alternate guide for PubMed, where you can find basically the corollaries for like saving medical research and medical data. And since then, they put together a bunch of other related guides. So I would encourage you, if you haven't looked at these resources, to go ahead and check them out. And then the work that we've done, these are just some examples of data sets that we worked on in the library that we contributed to saving and putting in Data Lumos. So kind of a broad spectrum of stuff: environmental science, library science, some of the data sets from USAID, and some medical stuff as well. Really a hodgepodge of things that we put our heads together and rescued all that stuff. In doing our rescue stuff, we're putting most of those data sets into Data Lumos. We do have a GitHub repository. We don't host any of the data there because it's too big to host in this repository. But we do have basically all of the code that we've written, like screen scraping code that we've used to download and save the data sets. Is that door, let me just interrupt, is that door locked? Like, can people actually get in there? If there are just like folks standing outside of the door. Okay. So we have this GitHub repository. We save a lot of our code. So if people are interested in doing their own screen scraping, we now have this body of existing code that folks can use to like get started. The other thing that this GitHub repository does is it gives you information about how to get to the data that we have saved. Beyond using Data Lumos, we have like a files 22 at Brown server where we're storing all the data. But more than just being a simple server, that server is actually a Globus endpoint. So Globus is a system or a system or a mechanism that you can use for exchanging big data sets between two different endpoints. So for example, downloading data like through the internet can be really cumbersome once you have big data sets because the web browser is kind of limited and it gets in your way. You can have connectivity issues. What Globus does is it provides like a secure channel for exchanging data that doesn't go through a browser and that is designed to be more secure. And if there's something that's interrupted in terms of the connection, it's able to deal with that interruption so that you don't have to start over again. It's able to pause and then pick up where it left off. And the way that it works is that Brown has an account with Globus. Globus was created at the University of Chicago, so a lot of schools have access to it. If you log into Globus, you can do a search for this collection. And this is basically the collection of all of the data that we have saved. And then you'd be able to see that in this kind of old school looking FTP-like interface, where on one side you'll have all of the data sets. And then on the other side, you have to create your own endpoint so that you can transfer the stuff from ours to your own spot. There's some software that you can install. It's called Globus Personal Connect. Basically, you would download and install it on your laptop or your desktop, and that allows your laptop or desktop to become an endpoint. Once you have the two endpoints, then you can just transfer data back and forth. So this is helpful for folks that really want to get everything that's there. But for folks that are interested in just finding like an individual data set, then they can just go to Data Lumos and search it up and find it there. The big project that we're working on right now is this Highfield Open project. So Highfield Open was the Department of Homeland Security's GIS portal, where it was a one-stop shop for like emergency management data. If you wanted to go here and get GIS data about every school in the country, every single floodplain, every single power plant and power line, you could come here, download those layers, and then you can open them up in GIS, and then you would have those spatial layers. This portal was discontinued at the end of August of this year, so it was just taken down. Most of the data sets that are in here are available at other places because the DHS was not the creator. They were just aggregating data from census and NOAA and FEMA and other agencies. But now you have to go to like 30 different places in order to find all of that stuff. The data rescue folks thought that it was important that we take a snapshot of everything that's in here. I suggested that we do that, and they said, "Oh, that's great. Then you should do that." So I worked with another volunteer over the summer whom I've never met, but he downloaded a lot of the data through an API, and then I filled in the gaps with things that the API couldn't find. We have all that stuff on Globus, and now we're going through the process of getting the metadata and uploading all of that stuff into Data Lumos. So if you're interested in participating in rescuing data, you can contact me. We are looking for volunteers. I have folks in my little lab, student workers that are working on this, and then there are some data rescue folks who are working on this nationally. Before we move away to this and move into the hands-on piece of what we're going to do today, I should say that the Data Rescue Project and some of the other things that I've described are one approach to tackling this. And the way that I describe it, it's kind of like we're attacking this like we're millions of ants. So you have, it's this crowdsourced thing. All these little ants are crawling around, picking up these data sets and bringing them back to the anthill. But you could use another approach where you have like a small herd of elephants. So if you have big resources, a lot of technical know-how, there are different approaches that you can employ. So at the Harvard, I believe this was at the Harvard Law Library, they created this entire software package that allows you to basically crawl and download all of the data sets that are in some of these data portals. So they did a crawl of data.gov and basically captured every data set that was in data.gov and have archived it here. So if you want to go find that stuff, you can basically use their tools to go in there and look for it. Or if you have a bigger project where you want to do something similar, it is possible to take that software and deploy it. But it takes some expertise to do that. You also have to make sure you have a lot of space to store all these things. And the one thing with the elephants is that while they can take this big approach, they're kind of far from the ground. So they can't necessarily see all the little dips in the landscape the way that the ants can see. For example, data.gov, there are a lot of records in there that have no data attached to them. The data is actually stored on an external website, and the record is pointing out to that website. So in all of those cases, this approach wouldn't capture those things. It's only going to capture the things that happen to be in data.gov's actual repository. So to get the other stuff, you would need either a different elephant approach or rely on the ants to crawl around and kind of pick it up. I'm going to pause for a moment and see if anybody has any questions, because the next step is we're going to kind of move away from this kind of slide presentation and we'll go into a notebook and we'll do some screen scraping together. Will we get the slides? Yes, I will share them. Any questions before we go on? Okay. So screen scraping is one approach that you can use to basically rescue and save all of these data sets. The benefit of this approach is that obviously as you're writing the program, you're creating the documentation for how you did it. So other people can look back at that documentation, and you can also repeat the process in the future. Not all the data sets that are out here are going to disappear. Many will remain. Many will be updated in the future. So by writing a program, we can basically rerun the program in the future and create additional copies over time. But for the purpose of the data rescuers who are doing this, they may not need to scrape this if the page is pretty simple. If it's like a couple of clicks, it may not be worth your effort to like write the program or deploy it. In some cases, if the page is utterly complex, some of the things that I'm going to show you are probably not going to work. If the page is imminently going to disappear, well, then it doesn't really matter that we can do it in the future. We might as well just quickly grab what we can. And then there are some other options that you can use beyond screen scraping for saving stuff automatically or in bulk that I'll talk about in a little bit. But one thing I should mention is that we have to be good when we're doing this. So if you're using these approaches, you should only use them for like open data and things that are in the public domain. Websites that are copyrighted, we have to follow kind of the terms of service for what they do. And when you're doing this, we have to also make sure that when we're making these bulk requests, we're putting pressure on a web server someplace, and we want to make sure that we don't put undue pressure. So we've all been, going onto websites and you get these annoying things. Are you a robot? Yes or no? Can you fill out all these little grid squares to pick out all the traffic lights? Those are all mechanisms to basically prevent people from doing what we're about to do. But in our case, we're not doing it for malicious purposes. We're doing it for good. So just remember to be good. I should mention before we get into screen scraping, a big alternative is that if you are getting data that is in a kind of formal data portal, many of those portals will have a mechanism where you could use an application programming interface or API to directly pull records or data sets into a program, and then you can save them. So if a data portal has an API option, that might be preferable to doing any kind of screen scraping. So in this example, this is a Python script that shows you how to use the Census Bureau's API. And essentially what you're doing is you have this link, and instead of being a link to a website, the link has, you basically build it with these different parameters. So in this case, with this basic link, I can put in the year, the name of the data source, and another name. And then I can build a link where I put in information about the state and the county. And then I'm basically able to take that link and send it out to the Census Bureau, and it sends back a package of data that comes directly into my program, which looks, basically the output of that script is this. So instead of like going through a page and figuring out how do I scrape all this stuff, I can just use the API and ask for records, or in some cases, some APIs can handle files. So when we did the High Field Open project, it had an API. You could construct these links and then go out there and basically grab an entire file without having to do anything else. The trick to using these is that for every API, you have to basically read through its documentation and figure out how do you ask the questions that you need to ask in order to get the data back and returned to you. In some cases, though, APIs won't be the answer. Like this example with the Census Bureau. If I was tasked with saving all of the Census Bureau's data, this would be a terrible approach for doing this. There are literally hundreds of millions of records. So I would never want to go down the road of having to download these record by record. Instead, the Census Bureau has an FTP site where we can download entire databases that have complete data sets in them. So instead of doing that approach, I would do the bulk download approach instead. I guess the moral of the story here is don't start out assuming that you're going to screen scrape. Look at the data. Is there an API? Is there a bulk download option? Figure out what the most efficient approach is going to be. But if you decide that screen scraping is the answer, then also spend some time looking around at the different websites. So agencies like NOAA are not just going to have one website, they'll have dozens of them, and they're geared to different users. Like this one for finding a time series on climate data at the county level. This is designed to be very easy for people to go in there and hit drop-down menus and create a basic selection. But if you were to try and scrape this, it would actually be very complicated. Again, because there's like a database under the hood and there's all this JavaScript that's operating in here. So instead, I would spend time searching around this site, look for some little link to the bulk download page, which will bring you to something that looks like this. Something like this is like uber simple to scrape. Like this is barely even a web page. This is really kind of like a directory listing. So again, before scraping, you want to find like the ideal page to actually do the scraping from. For the benefit of those of you who are not from the 1990s and you didn't have to create web pages by typing all this code by hand, this is a basic example of HTML. This is the markup language that is used to write web pages, usually done automatically by different software and AI these days. But if we were doing this by hand, this is what it would look like. HTML, you have these tags that mark up the content and basically give you information about that content, how it's organized on the page, and also how the web browser should be displaying it so that this thing is a paragraph, whereas these things are links. And our job here, if we want to download files by doing screen scraping, we want to look at the HTML and identify the section of the page that has the links that we want. And then once we've found that section and we found the links, then we can go out and get them. Using Python, there's a module called Beautiful Soup, which allows us to basically take this HTML and it parses it and it puts it in a little container for us that makes it easy for us to pull out specific things like this division. And then once we've identified the links with the soup, then we can use this request module to say, okay, now that I found this link, I want to go out and actually save the file that's here. Rather than dragging you through more slides, what we're going to do now is actually go out to an IPython notebook and you can get some practice doing this yourself. So I've created a little GitHub repository that has this notebook. If you will punch in this URL here at the bottom, it will take you to this repo and we'll get access to the notebook. So this is just at the Brown University Library's GitHub page. It is the Python screen scraping tutorial. If you go out and search it up, Google was not able to find it yet, but DuckDuckGo was, if you just want to do some keyword searching to get to this page. Otherwise, just take a second there and hammer out that URL and get to the notebook. So github.com, Brown University Library, GeoData _ screen scrape. So I see somebody had some trouble getting to the page, but I was able to get there. It is live. Is everyone, can I see in the room? I get some nodding heads. So this is where we're going. And what we're going to do here is that I know that obviously Brown is a Google shop. That means that we all have access to Google Colab, which is Google's basically online sort of notebook for Python and R. And what we'll do is we'll basically go through a link and open this up in Colab so that we can all run it in there. All right, so once you are able to get to this page, and just so people actually, I'm not thinking, for the benefit of folks in the chat, I can actually share the link with you. There you go. Sorry about that. Duh. So from this page, I'm going to go to the notebook, pythonscrape.ipynb. And that'll open up the notebook within GitHub. And then at the very top, there's a little some trickery here where we have a URL. If we click on this URL that says open this notebook, that should open it up in Google Colab for us, provided that you are currently like signed in with your Brown email account credentials, etc. And that gets us, opens the notebook in Colab. And then this box at the top where it says Google Colab users run this, this will basically take that notebook and clone it and put it into our little Google Colab space so that you have a copy of it. So I'm going to go here and just run that cell. Warning, warning, yes, run it anyway. Fingers crossed, it should work. Success, it says. And if I open up on the left-hand side here, my little folder, it shows me that indeed I've been able to, it copied it over there. Everybody seem good to proceed? So what I'll do is we'll walk through these blocks and I'll talk a little bit about how it works. So at the top here, there are some modules that we're going to import. And I'm going to run this block up here to import those modules. Most of these modules are a core part of Python, and I'll mention what they do when we actually get to the part where we use them. The Beautiful Soup module and the requests module are not a core part of Python, but they are third-party modules. Since they're so often used, if you have Google Colab or a distribution like Anaconda, they're automatically included by default. But if you were running like a vanilla Python installation, like just on your laptop on a Mac that automatically came with it, you would have to use like pip install in order to install those packages. All right, the next thing we have, the next block here are just some variables. I like to hard code my variables as many as I can at the top of the screen in case they change. I put the URL of the web page that we're going to scrape. I've also put in just hard coded some information about the data set and also for your name. So you can actually put this in here too. The idea is that this information will output this to a metadata file at the bottom when we're done. And then the last thing that we're going to grab is that we're going to use Python's module and just get today's date. And we're going to save that as a variable called today. So I'll run that block and it's done. And the last preliminary is that when we download all this data, we don't necessarily want to stick it in the same place where our program is. Like the default is anything that we save will be saved in the same folder as the program, which is not ideal if we're downloading a lot of stuff. Let's make a folder. So I'm going to create a folder called out folder, and we're going to call it downloaded. But then we're also going to tack on today's date that we grabbed up here. The OS path module in Python, it's what you use for working with building directories and navigating folders on your file system. I'll run this. And basically this says, if this path called downloaded today doesn't exist, then please go ahead and make it with this make directory command. And evidence that this worked, if I hit the little folder, I should see a little downloaded folder here. The benefit of doing this and also attaching the date is that if we run this program tomorrow, it won't wipe out everything that we did. It'll create a new folder for tomorrow so that we can, basically this will allow us to save data over time without the danger of overwriting things. All right, what is the web page we're actually going to scrape? So down here, I have a link to the IRS exempt organization's business master file extract. I'll right click on that link and open it up. And here it is. So this is a database that contains every nonprofit in the United States that's registered with the IRS. And they have segmented this into individual state files that are CSV files. So, but as a data rescuer, I'm not interested in just these files in the middle of the page. At the top, there are links to a PDF file that includes documentation that I want to have so that I can interpret the files. Floating down here at the bottom are a bunch of other files. So what I want to do is I want to make sure that I write something that's going to capture everything on the page and not just the stuff that appears like most prominently or obviously. So up here, we have a few commands that I'll run them, and then we'll take a look at what the variables actually are. The first is that we're going to save a variable called web page, and we're going to use the requests module to get that URL, the URL that we defined up here for the website. Once we do that, then we can call on the soup, and we can tell the soup, hey, take that web page and turn it into soup. And the soup is basically a containerized object that will have all that HTML in it. And then once we have that object, we can do things like get things out of the object. So let me let me add a little, oh, I'm used to using Jupyter all the time. Let me come down here. I'm going to add a little block. If I've run this block, if I type in, for example, the page title, and that tells me, so that's the page title. That page title is a tag that was in the HTML of the page that we were looking at. The actual container, what is that? The container is a section of the website that I wanted to pull out and then look through in more detail. How do I determine, though, what that container should be? Up here, I said container soup page, find this division tag for this class. Well, how did I do that? Coming back to the actual website, if I right-click on the page, I can basically view its source. This will vary depending on what web browser you're using, but every web browser has something where you should be able to right-click on the page and take a look at the actual code that is behind it. the code is going to look like a hot mess. There's like tons of stuff on here. So what we're going to do is, this code is going to contain like this header and all of these drop-down menus and then the navigation stuff on the side, all stuff that we don't care about. What we really care about is the content that begins with this paragraph. So I'm going to copy that sentence and then come over here into the HTML, and I'm going to do Control F. And at the bottom of the page, I'll paste in that sentence, and then that drops me down into the middle of the web page and says, okay, that's where that paragraph is. Now that I know where that is, then I can come back up here and start looking at these different division tags, which represent subsets of the page. And I can basically try and select one that is going to capture the content that I want. This is a bit of trial and error. So I think what ultimately I settled on was this one. And then I came back over here, and that's what I put up here as the container that I wanted to find. But again, this is going to take trial and error. You'll do this step first, get that stuff, see what falls out into this container. And if you didn't capture it, you can go back and try and find like another candidate. You can do this with these division tags, but you can also do it with any kind of container that is in the website. So for example, all of this stuff down here falls into a table. If I just wanted the table, I commented this code out, but I could specify, finding that table based on the fact that it's a table and figuring out what its name is. The last thing that I wanted to do is that once I have that container, I want to find all of the links that are in that container. So anything that has the anchor tag. If I come down here and type in the word links, this is what it grabbed. So I can kind of eyeball those links and make sure that, okay, within this container, does this contain all of the links that I want? If it does, then life is good. If it doesn't, then I go back and I try and find some other object in that page that I want to try and search through. But not all of these links are things that we want. This is just, we've narrowed things down, and now we have to narrow things down a little bit more. If we go down to the next block, we're basically going to look through all of those links. For every link in the links that I've saved up here, if that link has an href in it, which is the signal that this is a link to a page, then I want to look at that link more specifically and see if it ends with any of these promising file extensions. Is it a PDF? Is it a CSV? If it does, then that's something I care about. What I'm going to do is that I'm going to basically get the file name that's associated with that link. And what we do there is that we take the link, we can split it up into pieces based on the slash. And the very last thing, -1, means we can go to the end of the link and read over one spot, and that should be the name of the file. And then I want to save that file and the URL into a little dictionary, which is a series of key and value pairs. So if I just run this, and then I'll add a little box beneath so that we can take a look. And that looks like, whoops, sorry. Looks like that has what we want. So again, we did that by crawling through the links, making sure that it has the href attribute, which means that it's an actual clickable link. And then once we do, looking to see if it ended with one of these extensions. And then if it did, we take this link and split it up into pieces using the slash. And by default, this -1 here, the last element in that list is going to be the file name. So then we'll take the file name and basically say in the dictionary, we're going to create a record where the key is the file name and then the value is the link. So that gives us this little dictionary of data files that we want to save. Once we have that, then we can actually do the real business of downloading the data. We're going to look inside that little dictionary, and for every key and value in the dictionary, we're going to basically try and get it. I'll run this block because it's going to take a little bit of a while to run. And down here, what it's doing is that you can see that I have a message here that it's actually downloading the files. So what this is doing is it's saying, all right, for every key and value in the data links dictionary, we're going to try and get the data by saying, all right, we're going to use that request module and we are going to get the value, which in this case is the link. And then we're going to do this thing, which is raise for status. And that essentially says, when you went out to get this, were you successful? Did you get something or did you end up with nothing? If you ended up with nothing or got some kind of mistake, it will bail out of the try loop and move down here to this exception block and say, uh-oh, we got an error message. I want to hold on to the error message and save that in a little error dictionary. Otherwise, if life was good and we got it, then we can proceed. We basically are going to use the OS path module and we're going to open the output folder that we created. And then the key is the name of the file. And we're going to write it into that folder. This does the writing. And then when we're done writing, we can close. And then we have a little counter up here with the I where we can keep track of how many things we did. And then at the bottom here, we're just printing out this message telling us everything that we've downloaded. If we were successful, if we go back over here to our file system in Google Colab, you can see, et voila, we've actually captured all of these data files. But it's not just about the data. So a few little things to wrap up at the bottom. It may be helpful to save the actual web page because the web page will actually have content in it that tells us about how the data was organized and maybe other useful information. To save the web page, we'll basically just say, all right, we're going to save this as a web page, and I'm going to stick today's date at the end of it. And it's very similar. We open it up, and we're basically going to write the web page into a file. Metadata is always good. We're going to do something similar where we'll create a little empty text file, and then we're going to write a bunch of stuff in the text file. We're going to write basically stuff that we saved at the top that I hard-coded, like my name and the URL. We're also going to write in here the page title that we grabbed with the soup, and also how many records we grabbed and what today's date is. If life was bad and there were any mistakes, I won't go into the details here, but it's very similar. We have a dictionary with mistakes that we recorded, and then we could also write that out if there were mistakes. Come over here onto the left. Let's see. I don't want to open something. DC is pretty small. So if I double click and open that up, you can see over here, this is actually what we managed to save. So that's the data file. Other things, like if we wanted to see the metadata file that we created, here's the metadata file. That's just a simple text file that wrote out things that we hard-coded or things that we grabbed as part of the process. The web page is there too. It's actually going to show us the HTML. But in saving the web page, all it's doing is saving the content. It's not saving any of the styling or formatting or any of that stuff. So this notebook is there for you to experiment with. Up here, I had some other options, like if you didn't want to grab everything in the division, you could basically just get everything that was in that table. You can go back into the web page and see if you can pull out things that are more nitty-gritty or specific. Of course, this worked marvelously here. It was like a simple thing because I chose a page that I knew would work very easily. If things don't go so easy, how do I get my my slides back here? Most of these, I'll share the slides with you. These are basically just hard-coded things of the things we did live, so I'm just going to skip over them. One thing I should mention is that if you were doing a really big data set, like this was small, but if there were thousands of files that you were doing, you can use this sleep module to build in a pause. And this is one way that you can be nice and not like hammer the web server to death. Like in that loop, you can do, once you've counted to a number that's like divisible by 100, you could like pause and sleep for 5 or 10 seconds before proceeding on to the next thing. The links that we looked at were absolute, which means that they included the full path to the file. Some websites, though, will use relative links like this one, where it's basically just saying below this subfolder where the data is stored, there's a data file below there. Python's response module is not going to, or request module is not going to be able to deal with that relative stuff. So you'll have to take an extra step of building the entire link. Basically, you could hard code the root link for the website at the top. And then this is just doing the things that we demonstrated in the notebook. And at the bottom, you just add them together. You take the URL and then add it to the link that the relative link, and then you'll get the full path. And then Python will be able to do its thing. A different caveat is that if the link that you're looking at is not to a data file, but to another page where the link is stored, then you have to think about building another loop into your program where you're going to loop through a series of pages. And then once you get to that page, then you'll actually do the downloading on that page. So it's basically an extra loop. Some pages will have like certain parameters in them. So for example, if there were dedicated pages for the US, Canada, and Mexico, and I knew what those pages were, I could basically create a list at the top and pass those codes into the link and then iterate through those links if I knew what they were. Really messy stuff, if you have gigantic files, there's a chance that what I just showed you here, you might run out of memory and it won't be able to continue. This trick that I found is basically a way of oh, I'm sorry, I'm looking at the wrong thing. This is the stuff that's too big. If you're dealing with files that are too big and you run out of memory, instead of doing that simple download that we were doing, this is some code that basically allows you to stream the files in chunks, and you can specify how big the chunk is that you want, and that way you won't run out of juice. I basically just ran into this problem one day, searched it up, found this solution, and it works pretty good. If you look at the HTML, if you look at the page source and are like, oh, where's the content? There isn't any. I can't find it. It's probably because that page is using JavaScript. And instead of the HTML having the content embedded in it, JavaScript has to dynamically produce it and insert it into the web page. If you run across that, you're not going to be able to scrape like I just demonstrated here. Somehow you will need to figure out how to actually render that page and then scrape it. One of the things that you can do is that there's a module called Selenium, which basically allows you to automate using a web browser so that you can simulate actually clicking on a button and putting in a drop-down menu, and then it will give you the page that you can then scrape. Your mileage will vary. It's kind of a clunky thing to use, I found. A better thing might be if you know how to use JavaScript, which I don't, but if you do, since these are JavaScript-backed pages, web browsers will have tools and plugins built in, like web developer tools, where you might be able to plug in some JavaScript code and then get the output that way. So I know that was kind of the last thing I'll mention in terms of efficiency. I wrote all this into a notebook because it's easier for us to demonstrate and walk through together. In writing these programs for real, I would never use a notebook. The notebook is great if you want to iterate through all of the steps and see what you're doing so you can figure out what to do next. But notebooks introduce a lot of overhead. They operate in a web browser. They can slow things down. And for these processes, you don't necessarily always need to see the content to make a decision. Instead, I would just write like an old-fashioned sort of program in what your favorite developer app and just use that instead. You'll save memory. I also did not use pandas or any of the data science modules for data frames. Those also introduce tons of overhead. So if the data is big, you're better off relying on the traditional like dictionary and list data structures for storing things and not using a data frame. So that's my whirlwind tour of screen scraping. I hope that was useful to you. But yes, once you get the hang of it, like it becomes very easy to do this and not have to go to a page where you have to click on 500 links to download stuff. You can just do this instead. And you can rescue and save some data. So this is my contact information. You are welcome to reach out to me if you ever have any questions. And lastly, for folks who came in late or didn't have an opportunity to do this, you are welcome to, well, you're encouraged actually, take a picture of this thing or hammer in the bit.ly and tell the DSI folks that you came to the workshop today. Let me see if anyone has any questions. Yes. Oh no, picture taking. Okay. And I'm going to look in the chat as well. Some helpful tips about using Chrome. Yes, I'm still using Firefox. I'm a bit vintage in my web browser choice. So I've shared these slides through the chat for the Zoomers. But if you registered for this workshop, then I'll pass it along to Aspen and the DSI folks, and they can share these slides with you. Oh, is there a question there? What's my next initiative? I estimate that the Open High Field, saving all of the GIS data in Open High Field is probably going to take us the rest of this semester. Once that's done, it's a good question. For the longest time, especially when we were in the Doge phase of the government, the data rescue was like a firefighting mission where there was an emergency every day and we had to jump on and save something. That's not the case anymore. Like things are being removed more slowly and more deliberately. In terms of the next phase, I hope that we can maybe start to think more strategically about what are the things that we want to save and how can we make sure that we can continue to do that over time. One idea would be to work with the rescue folks and see what their priorities are. The other possibility is to work here at Brown and just talk among us, among the faculty and the staff and the students, and figure out what are the data sets that are really important to us. And maybe we should make sure that we're targeting those and saving them here. And at the same time, that might help other people throughout the world too who are interested in those things. So the DSI does have a group of people that are meeting to kind of strategize around this. But yeah, more broadly, I think that's yes, Cass.
A quick pitch for it's awesome to work with Frank. If you ever have anything, please reach out to Frank. That's just a general Frank appreciation. But also, it's really interesting doing this work now. Even there's already been changes, like things that disappeared came back, that new things disappear all the time. So it's very like use the like the tech that still exists, but it's very all of a sudden it's very politicized and it might be taken offline. So I'm wishing really being yeah, just getting
That's kind of like data related that we can help you with from the library. We'd be happy to work with you. All right. Thank you very much.
You can look this also one conversation, but I would like to know about the GIS data sets. If there is like a centralized way at the university to make calls to these data sets, or a little bit on that.
So this project in particular, I worked with another volunteer over the summer. He used the API to download as much as he could from this repository. And then for everything that failed, they were usually really big data sets that couldn't be transferred. I kind of filled in the gaps, identified the sources, and then populated them. We have this information now sitting on a file server, and it is on the Globus file server, so people can transfer copies if they'd like. And we're also uploading the files individually into Data Lumos, which is fine for at least providing people access to them. But it's not exactly recreating like this GIS repository the way that existed. And it's also capturing just these files that they existed at that point in time, which is important for now and maybe far into the future when people are doing historic stuff. but this is going to be stale at some point. So one of the things that I'd be interested in is knowing, like, so at Brown, what are the GIS kind of databases and data sets that researchers here are interested in? And then those are things that we can target and come up with, you know, a process and a strategy for saving them. And while we can always stick them on a web server for people to get, I also wonder if there's a way that, you know, is there a portal that we can create where we can easily put those data sets and populate something that's more user-friendly that people can access on an ongoing basis? Yes, Nia.
One of the benefits of that kind of approach is it's useful for researchers at Brown. And then also for anyone else who's using it, there's some sense that responsible people at Brown University have done this work and are taking care of this data. And I just wonder, for a large project like this that does have so many people working on it, what does sort of trust look like? And I don't know, are there conversations about, like, as a kind of a longer term basis, how do users of this data, you know, find that trust? Who's authenticating or verifying and helping people know when to trust data, or what the data set that they need to do more research on to verify that something that's been scraped appropriately and stewarded appropriately.
Okay, so repeating for the Zoomers, so Nia was asking about, you know, in scraping and saving these data sets and we're providing them somewhere else, how do we give users a sense of, like, that these are authoritative and that they were done, that the information was all captured and that it's correct? And again, I think as a big picture, like, a lot of folks in these different projects haven't focused very much on that yet, because it was still very much the firefighting emergency of let's grab everything. But in looking at, like, at this project, I can see that we're missing records. So let's fill in the gaps. We're missing metadata in some cases. So can we find the metadata from somewhere else? Can people actually open these files and make sure that they're not corrupted and that they're going to work? I'm not sure, because a big part of this process is that for the longest time, nobody worried about this. This was a thing that, yes, the federal government is out there and they're providing access to this, and we don't have, you know, there's no concern here. And now all of a sudden it's like, well, maybe that's not a good idea. It's good to have multiple copies of things. So how do we figure out how to do that? But yes, it's important because we can go into some of these repositories now and there's like very minimal metadata, or things weren't, you know, millions of people are doing this, so it's not standardized. In some of the things that we did for this project, I did write some code that we took each of the GIS data sets and just plotted them using Python. So not like a nice looking map, but just like I was making a graph, plot all these polygons or points on a chart so that I could quickly go through them and see that was anything produced. Otherwise, how would I look through 500 data sets to know that they're complete? And then, of course, there's the issue of, well, maybe this is why artificial intelligence is here to help us. Is there a way that we can deploy it to reliably, like, search through these thousands of files and verify their completeness somehow, since that's not something that it's feasible for all of us to do? All right. Well, thanks for coming.
I